All right, guys. Today we're gonna begin with a new topic, a topic that you guys hopefully have seen in ninth grade and maybe eighth grade, seventh grade, and all of those, right? But it is new for 10th grade. So we're gonna start with a little bit of a review, and then we will continue from there, right? The topic is probability. That is the topic. So we have two types of probability. We have theoretical probability and experimental probability, right? And those two are pretty similar, but have radical differences, right? We're gonna begin with the usual one, the one that you probably know about, the theoretical one, theoretical probability. What is a probability? All right, a probability is nothing more than a ratio. So we're gonna call it like this, a ratio, right? So one number over another number. For those of you who don't know or don't remember, that is a ratio, a fractionary, a division. One number divided by another one, a ratio, right? So that is the idea behind probability. Now, what are those two numbers? Okay, finding those two numbers is the whole question when we talk about probability. So over here, this is going to be the success, and I'll explain this a little bit later. I'll explain this more a little bit later, right? This is the success, and this is the total of possibilities, right? Success and totals, right? So what I mean by probability and by a success and a total is that in probabilities. Oh, by the way, guys, go ahead and turn on your cameras. I forgot to say you about that. Go ahead and turn on your cameras. Thank you, all of you, please. Those of you who can. If you cannot, if you have difficulties with the camera, tell me in the chat. Thank you. Hey, Garzon, like your style. All right, so success over total, right? So the idea of total, which is always the thing that you should begin with, you should begin by doing the denominator always in a probability, is every single possibility that you can have in your experiment. So let's begin with an example. Let's say we're gonna throw a coin, right? So we have a coin here. Say this is a coin, right? And in the coin, right, when we throw a coin, when we toss a coin, any one of you can do it. You can take a look at a coin that you may have in your pocket, right? You take a look at a coin, and you have two faces, right? You have the numerical face, right? The numerical face, which we're going to call heads, the number. So if you're throwing a 500 pesos coin, then the face that has the 500 is going to be the heads, all right? That is the head. And you also have the other part. In our case, in Colombian coins, we have a shield, right? A shield or an animal, right? I don't know if it's a shield or an animal in 500 coins. I don't know. You guys can tell me. We have a drawing. So that's going to be our tails. So we have heads and tails. This is what I mean by the total. In this case, in this experiment, toss in a coin, we have two possibilities. We can either get a heads or we can either get a tails. Meaning our total for the probability, let me write it here. The probability of the event is going to be 2, because we have total, right? The total is 2. We only have 2 possibilities in here. Sure, some of you might say, but teacher, what if my coin lands standing vertically? I mean, really? Can that really happen? No, for real, no. Because if it is one possibility, if for real your coin could, maybe, perhaps land vertically, then we should count that as a possibility. But physically speaking, because of the way you toss your coin, there is no way, it is impossible that your coin lands vertically. Simply because the coin is spinning, right? The coin is spinning. So the moment it hits the ground at any angle, it would have to continue spinning, right? So it cannot just stand. It cannot happen, right? So we only have 2 possibilities. The third possibility of the coin landing vertically doesn't exist. That possibility is a lie. It doesn't happen. So we have two possibilities. Our total for this probability will be two. Two possibilities. Okay? That is the idea behind totals, right? Now, if I change the experiment, let's change the experiment right here. Let's change the experiment. What if I toss, in this case, I am not going to toss a coin. I'm going to throw a dice, right? So this is one, let's say this is two, and let's say over here we have three. One, two, and three, right? This is going to be a really awful dice. Right? We have our dice in here, right? This is two. Let me make it a little bit bigger. One, two, and three. There, right? We have our dice. Okay, so what are the possibilities when we throw our dice? Okay, if we take a dice, I mean, any one of you, again, can see this. We have 6 faces, right? Any one of you who has ever used a dice, we know that we have 6 faces in the dice, right? So we have the face of the number 1, the face of the number 2, the face of the number 3, number 4, number 5, and the face of the number 6. In total, we have 6 possibilities. This is supposed to be a 4, right? In total, we have 6 possibilities. So again, if I want to calculate some probabilities in this other experiment, I would do the same. The probability of that experiment of that event will be something over the total. Again, success over total. Now, I am not filling in the success in here, and I will not fill in the success in here. I'll explain why in a minute. But I just want to focus our attention on the idea behind the totals, right? In this example, we had 2 possibilities. That is our total of possibilities, 2. In this case, this experiment, tossing a dice, have 6 possibilities. That is the total of possibilities. So whatever the probability will be something over 6. Are you guys following me here? Okay, I can see 1, I can see 2 people saying yes. Okay, what happened with the rest? Go ahead and write something in the chat, or thank you. All right, thank you guys.
Yes.
Beautiful, thank you. Thank you. Guys, remember, Lily and I think it was Garzon, maybe you did something like this, right? You are connected with me. Thank you, appreciate it. If you're not, just write something in the chat, right? You can go like this. That's good as well. All right. Thank you. Thank you for the people who say yes now. Thank you, guys. Appreciate it. Again, this is all theoretical, right? This is all what you guys have been studying from 9th grade, maybe even 8th or 7th grade. I don't know. This is just a little bit of a review. By the way, what is the number that we are going to write in here? What is this number? And this number in here. Remember, a probability, let me write it here. I didn't do it in here. Probability of the event. I didn't do it here. There. Ah, you can see the P. No. A ver. E. And then the P. There, better. All right. A propósito, mira, no dije esto, pero entonces lo voy a decir aquí de rapidez. Esta P paréntesis E. Mira, P paréntesis E. P paréntesis E. Ahí lo que dice es la probabilidad del evento es. Eso es lo que dice ahí. Matemáticas lo usamos como para decir cuál es el evento o qué es lo que estamos encontrando. Aquí estamos encontrando una probabilidad, por eso le ponemos P de probabilidad. En inglés es lo mismo, probability of the event. O en algunos casos lo llamamos probability of the experiment. Cualquiera de las dos funciona, ¿listo? ¿Cuál es el evento o cuál es el experimento? Depende de cada ejercicio. En este caso era lanzar una moneda. En este caso era tirar un dado. Diferentes experimentos nos dan diferentes probabilidades. All right, let's continue. So at the beginning I said the idea of a probability is the success over the total. That is the probability, right? A ratio, a division of 2 numbers. That's it. The question is, now that we know the total, how do we calculate the success of an event? Well, the success of the event is the amount of possibilities that give us what we want to find. Give me just 1 second. Danny said something in the chat and I have to read it. Mari Zuleima, Gus, Dani dice que tiene problemas de conexión y te escucha trabado. ¿Me escucha trabado? Dani dice, Gus, se me está saliendo porque tengo mal internet. All right, Danny. Thank you. Danny, just if you have difficulties with the internet, you can always go back and see the video. All right. And don't worry if you leave the meeting because I don't know because of the internet issues, it's fine. I'm not gonna say that you're not here. Right? Just try to come back as soon as possible. All right. So let's say in this example, right, when we toss a coin, let's say the success we want to have, the success is getting the coin to land on a head. That is going to be the success. All right. So if that is the success, how many of our possibilities are heads? That is the idea behind success. Out of all the possibilities, we have to count how many of those are the ones that we want to take into account. The ones that we call success. Okay. So this one is a success. Right there. This one is a success. Landing the coin in heads is a success. But landing the coin in tails is not a success because we don't want tails, we want heads. In other words, 1 is the amount of success. The probability then will be 1/2. Of course, you can always write down probabilities as decimals, right? This is 0.5. And of course, decimals can be written as, how do you call these ones? Percentages. So you can call this 50%. Right? All right, let's take a look at another example in here. This one, the dice. Let's say we want to have, I don't know, an even number. All right, what is the probability that when you toss when you toss or you throw a dice, you get an even number? All right. So we have the totals. Now we have to count out of these 6 possibilities, every single possibility, how many of those are going to give us even, are going to give us success? In our case, we want even. So this is a good possibility, right? Number 2 is even. Number 4 is another good possibility, is another even number. And number 6 is another good possibility, right? So we have out of the 6 possibilities in total, 3 are going to give us success. So that is the idea behind the success. In here, the success will be 3. Again, just like the first exercise, this is a good probability. You can leave it like that, or you can simplify. This is 1/2. You can simplify that, right? Or you can go even further. You can change this into a decimal, 0.5. Or you can pass it to a percentage, 50%. Now, in this case, take a look. My probability of the first event is the same as the second event. That is just because I am lucky. This happened because I am lucky. Different events should give us different probabilities. Let's take a look at this. What if I change the event in here? What if I change the event? Let's change all of these. Erase this, right? And let's count again. Let's say that now the event will be, instead of getting an even number, let's say we are looking for numbers that are multiples of 3. En este momento cada uno de ustedes debería estar pensando, ¿múltiplos de 3? ¿What? ¿Qué demonios es un múltiplo? ¿Cómo así? No entiendo. ¿Qué es un número 3? Múltiplos de un número el que sea, son los resultados de multiplicar ese número por 1, por 2, por 3, por 4, por 5, de manera continua, por 6, por 7, por 8. Entonces, múltiplos del 3 son 3 por 1, 3. 3 por 2, 6. 3 por 3, 9. 3 por 4, 12. ¿Me van siguiendo, mis niños? Okay, cool. So let's think about which of these 6 numbers in here are multiples of 3. Again, multiples of 3 are numbers that are results of multiplying 3 by any other number, right? So this is a multiple of 3. 3 is a multiple of 3 because 3 is the result of multiplying 3 times 1. All right, so we have one success. Can we have another one? Sure. 6. Right? 6 is another number that is successful in our event because 6 is the result of multiplying 3 times 2. So 6 is a multiple of 3. In our case, just like Karen said in the chat, the success will be 2. And the probability will be 2 over 6 because we have 2 successes. Different events will give us different probabilities. In this case, we can simplify this. So this is 1 over 3, right? Or we can pass these to decimals. Of course, we have to round. In this case, we're going to have to round. So I think I teach you this, right? Back in the school. Do you guys remember this? This sign? Okay, Urasan is saying yes. Thank you. Karen is saying yes. Thank you, guys. All right, this sign is for rounding, right? This is an approximation, right? 1 over 3 doesn't have a precise decimal. It has an infinite amount of decimals. So we cannot say equal. We have to say round. And we can round this to, I don't know, 0.33. That's good enough. Again, we can round this to a percentage. This will be 33, I don't know, 0.3%. It depends on the amount of decimals, right? But I like this. I like this one decimal. All right, cool. So this is the theoretical probability. This is the one that all of you should be familiar with, right? The theoretical probability, there, right there. This is all theory. But experimental probability, that's different. Experimental probability, this one, it's different. Experimental probability requires you to count. Experimental probability requires you to actually do the experiment. Right? Let me do it here. To do the experiment. To actually do the experiment, right? So we're gonna do just that. We are going to do just that. This is what I want you to do, guys. We're gonna do this experiment. We're gonna throw a dice. Now, I want each and every one of you to please take just 3 minutes. 3 minutes. Go around your house and find me a dice. If you don't have one, you can always use one from an app, right? Into your cell phone. You can download an app, or you can use, I don't know, a page on internet. I am sure right now, if you go on Google and type dice, or I don't know, dice app or something like that. Emulator, right? Something like that. Online dice. Type something. I am sure if you do that, you are going to have a dice, right? And this is what I want you to do. Take a look at these, guys. Take a look at this. Where is it? This will be our table for the results. I want you to please fill in this table. Fill in this table. So you're gonna toss the dice one. You know what? Let me just do it here. Online dice. Online dice roller. Look at this. Look at what I found. Like this, half and half, right? Look at this. What is happening? There. Look at that, half and half, right? So I have the dice in here, right? So I'm gonna select 6 faces. No, what is this? No, I just want one dice. I don't know what's going on. All right, let's find another one. This one. So roll 1 dice, right? And roll the dice. Look at that. Look at that. I have the first answer will be 5, right? This is the first answer, 5. So what I want to do here in the outcome 5, Right there in the column of tally, I'm going to write just one line. I don't know, something like this, 1. Because I have 1, 5, right? If I roll it again, roll again. Now I have a 1. So here in the column of 1, I'm going to write a 1. We're going to continue this process until we get 50 totals. 50. We're going to roll the dice 50 times. And you guys are going to write down the tally, and then we're going to count. Let's see if I get 1 to repeat. 6. No, all right. Let me write it here. 1. Roll again. 6 again. All right, 6. So in this case, I'm just gonna do another 1 in here. All right, something like that. Okay, so now I have 2. This is the frequency. Let's say at the end of the day, I count. So I have 1 in here, 1 in here, and 2 in there. Right? You can do this in a piece of paper, in your notebook. Right? I recommend this. I recommend that you copy this table in your notebook and leave enough space for the tally to count. Right? And then you can do marks. That is what I recommend. You can do marks. But if you like to do Excel like I do, so you just copy this in Excel, and that is fine. All right. We will come back. We will come back when you guys are done. I'm gonna give you. Come on. Tossing the dice is absolutely simple. So I'm gonna give you 5 minutes for these guys. Just 5. 5 minutes. All right. I'm gonna cut the video here, and we will come back in 5 minutes. Wait, can I just pause the recording instead of stopping it? No, I don't think so. No. Gosh. Yeah, I know. Okay, cool. I'm gonna stop the recording, and we will come back when you guys are done.